Okay, for today's lab, I'm going to try and test different elements as electrodes to find out which would be the best anode and cathode in a battery. So what I have here is I have these electrodes, and these are just elements, or it could be a substance, that could serve as an anode and a cathode in a battery. So I'm just going to test all of these substances, and what I have here, I have some zinc metal, some copper metal, some iron metal, some lead metal, some aluminum metal, and some carbon. And the real reason I have carbon here, this is just a piece of graphite really, is just to illustrate the fact that we don't have to have metal serving as electrodes. So I have these elements, and I'm just going to combine all of them with each other inside of my little lemon here. This lemon just has a lot of juice inside that will serve as that salt bridge for our battery. So as long as I have two electrodes that have different standard reduction potentials, and I connect them with a wire, which will be my voltmeter, and I have a salt bridge to balance the ion, or to balance the charge, I can create a flow of electrons, which is really a battery. So what I'm going to do here is I'm just going to start out with my zinc. I'm going to put my zinc in my battery, and I'm going to choose one of the metals. So let's just do copper. So I'll put copper in here, and now we are going to touch my voltmeter. I kind of did this on purpose. You see how we have a negative value there? All I need to do is to switch my leads to find out, like, oh, here we go. So zinc and copper have a standard reduction potential difference of 0.96 it went up to. Okay, now I'm going to stick the iron in there. So zinc and iron have a difference of 0.49. Zinc and lead have a difference of 0.33. Zinc and aluminum have a difference of 0.08. And let's jam this little carbon rod in here. There we go. And then the zinc and the carbon have a 0.7, whoa, going up, 0.89. 0.90 it went up to. Okay, now that I tested zinc with everything, I can kind of get rid of my zinc, set that to the side, and now I'm going to use my copper over here. And I'm going to start by reacting or putting the copper with my iron, my Fe. So copper and iron are getting nothing. Let's move these around. Copper and iron, here we go. Now we're getting stuff. 0.44. 0.44. Okay, now let's do copper and lead. Notice that I'm just testing everything with everything else. Copper and lead, we get 0.56. So copper and aluminum, I get 0.76. And then lastly, copper and carbon, we get a, well, this isn't, when I'm getting a 0, I just kind of shift things around in here a little bit, make sure these two electrodes aren't touching, and I get a 0.13. Okay, I've now tested zinc and copper with everything, so I can kind of throw my copper to the side. Now I'm going to test iron, Fe, with the other remaining metals. So what about iron and lead? Those were touching. Iron and lead, we get 0.08 it went up to. Next is iron with aluminum. Iron and aluminum, we get 0.18 it went up to there. Well, 0.23. So 0.23. And then lastly, iron and carbon. We get, come on, I gotta sometimes roll my lemon around a little bit more. Okay. They were kind of touching there. Oh, there we go, finally. So it's something. 0.47. Okay, we're done with the iron now, so we've tested iron with everything. So now I'm going to get my lead and put my lead here and test the lead with the aluminum. lemon might also be getting a little used up here. So the fact that the lemon is a little used up and the juices aren't flowing correctly, what do you think that could be? Maybe a little source of lab error, even though you don't have to do lab error this lab. Or no, yeah, we do. So, okay, 0.05, not much there. Now let's do the lead with the carbon. Okay, lead with carbon, and I get 0.60. Oh, again, all these units are volts. Sorry, I'm not sure if I reminded you about that. Okay, now that we did lead with both of those, I can get this out. And then my last remaining combination would be my aluminum with my carbon. Okay, and then aluminum and carbon, we get a difference of 0.68 it went up to. So again, your goal for this lab was to figure out which combination of electrode will serve as the best combination in a battery / create the highest voltage. And then for this, I would like you to decide which electrode was the anode and which electrode was the cathode. And you do that by looking at that standard reduction potential chart that I showed you in the skill sheet. Okay, I hope this lab goes well. Email me with any questions or concerns.